Sorry for all the technical difficulties. I have no idea because I've not used Zoom quite a lot. We use
Yeah, no
Microsoft
worries, it
Teams for almost
happens.
all the gatherings that we do. So I am so sorry for the past 4 to 5 minutes that all of you guys have been waiting. And I'm glad that we've got to a state where we can communicate. And I think it's all good right now. Yeah.
Yeah, sure.
Awesome. Starting off, it's quite late here. It's past 9:30ish in New Zealand, and I know a couple of my friends are joining from other parts of the globe as well. So it's quite late, and I thank all of you for the different time zones that you are joining in, and just to hear me speak. Thank you very much. Is the voice not clear to you?
Yeah, Kirod, yeah, you can try to rejoin on your end. Your voice is clear, Richu. You can carry on. It's fine.
And in terms of the presentation, thank you for pulling that up. If you can go to the next slide, I can give a little bit of an introduction about myself before I join in and start talking about it. So as Yash kind of mentioned, I have been in New Zealand for a few years now. So I was a little bit of a background about myself. I was born and raised in Dubai. Then I went to India to do my bachelor's. I did my bachelor's in technology, and it was a very different field. I did it in media technology, and that was quite specialized. And it's very different from data or data science and computer science. So if any of you guys speakers are in here, and if you guys have been part of this conversation before where you wanted to get into data science and you haven't gotten into data science purely because you think that it's not something that you have been involved, I could not emphasize further than saying that you can always move into the field of data no matter what background you've got. So when I said media, it was more about sound engineering and whatnot, and it had a little bit of math in it. And that's when I realized that maths is just a small portion of the whole conversation. So I was very interested in how this would go forward. And that is where the whole conversation had even started about data engineering. And then I applied for the scholarship called New Zealand's Academic Excellence Award. So if you are in India and you would like to apply for math-based scholarships, which get you into data science related fields, I'd strongly encourage you to get into any of the scholarships that apply for New Zealand. There's like at least 5 to 10 different scholarships. If you want to reach out, please reach out via LinkedIn. I can help you with those processes. They're usually quite straightforward, and depending on the year, they keep changing. So that's how I came to New Zealand to do my master's in data science. It was called Business Data Science from the University of Otago. And then that's where I started doing this process of getting into this field and identifying what has gone wrong and what has been interesting. Right after graduating, or right even before graduating, I got this job offer as a data analyst in one of the biggest media intelligence company in the world. It's the second media intelligence company in the world, and it's called Meltwater. And they have a lot of analysis, and they create their own business intelligence tools. Like you guys may have heard of Power BI or Tableau. And media intelligence companies such as Meltwater, they kind of focus on building on their own platform and working their way through it. So I started off as a data analyst in Meltwater. It was very interesting. The conversations was absolutely brilliant, the conversations that I've had. It was a 6-month contract. I just wanted to get into the New Zealand field of data, and it was very interesting, to be honest. And then after that, I wanted to find a permanent full-time job, and then had come to another city in New Zealand called Hamilton, where I started off as someone that was in the middle of a data scientist role. The job title was called product scientist. So it's very product-based data, and you perform all kinds of analyses on it. And then I slowly transitioned into a data engineering role. So data kind of does have to exist before you can start working, right? So you might see this trend where people have more of a data analysis kind of background, and people to perform analysis on data, they have to have the best, I would say the best quality data. And that is a key responsibility of a data engineer. Get the data that you need, transform, process all the information you need, and produce it to someone. Yeah. And apart from work, I do a little bit of volunteering here and there, and mainly around the universities. So I've given a couple of lectures in the University of Waikato. That's another university in New Zealand. They've got a very good program That's not the university that I studied in for data science, but they've got a big data management kind of talk. So big data is the future. So we're getting data in massive amounts as we speak, right? So even moving forward, I would say that we would get to a state where we need that high amount of data coming in, and that needs to be managed. So data engineers play a key role in managing this data, and that's the space that I have gotten into. And just before I start getting into the presentation, technical stuff, there's one thing I personally am passionate about. It's languages. I love learning languages when I speak. So the guys who are attending, is there any language that you would like to learn? It can be a spoken language, or it can be a programming language like SQL or Python. If you guys can comment something in.
Let's see who wants to learn which language. We have around 80 odd participants. Let's see what is the kind of response that we can get.
All right. Yeah. SQL and Python are usually languages that people start working. Mandarin. Mandarin
yeah.
is a language that I started to learn, but then I stopped very quickly because I feel like you need to be around people who speak Mandarin to keep continuing.
Yeah.
And Oracle. Sanskrit is really
German.
hard. It's crazy hard. I've really tried doing it as well. German, I actually did study a little bit German. German's not hard, but it's a little boring when you get to a state where you just, they've got all these Goethe centers in India. So if you go to one of those centers, you can study German. If you're interested in studying a foreign language, I recommend French. If you know a little bit of English, it's relatively easier to study that. And in terms of Python and SQL, I would strongly say start with SQL. It's probably the easiest language that's closest to English. And then Python. Python is also very easy, to be honest, if you compare it with, let's say, Java or something much, much harder. So you guys can get into that. And yeah, French is absolutely great. If you study French, you can travel to, I think it's more than 25 countries. And that's a very good aspect to get into. And in terms of data engineering and languages, I would say you start with SQL. Everything that you're working in data engineering, it starts off with SQL and advanced SQL. It's not just joining a few lines. It's usually it's much more than that. You get into PySpark, and that's like another framework that involves Python and SQL. And then Python is the second language. So if you're good with Python and SQL, you can start off as a data engineer. Then you can find your way through it. Which really shouldn't be a problem getting your way through it. Right. Can you please go to the next slide?
Yeah, sure.
Right. I just want to start off with this conversation of what is data engineering, because I understand a lot of people, including myself, when I had started, I had very limited amount of knowledge in data engineering because there's no masters of data engineering. I've not found any university that at least when I did my master's, had a university that pushed forward things like data engineering, pure data engineering. So I see someone has raised their hand. Yash, do you want to wait till the end for that?
Guys, you can just post your questions in the Q&A section. We'll take that in a single go so that it doesn't break the flow, right? Yeah, sure. Richu, you can carry forward. Yeah, sure.
Because I still can't hear what you're saying, but I'm a good sign language leader, so I can read what your lips are saying. I think it's something that I've joined in as one of those panelists, and I can't hear other panelists maybe for some reason. I'm not really sure, but it's all good. It's all good. If you've got something urgent, can you please message, and it should be all good. Yeah. So yeah, I will continue with my presentation, and towards the end, if you've got something, please take us through. And in terms of data engineering, what is data engineering? So in the simplest form, data engineering is the process of designing, building, and maintaining systems and infrastructure. Just think of that. And what do we do in that? We collect, we store, and we process data. That is pretty much the end of the whole conversation of what data engineering is. It's a very complex and rapidly evolving field. I don't know a lot of people who've started off directly as data engineers in the field of data. Not because they're not technical enough, it's because you need to understand the data side of things, the analysis side of things, and then you work your way through to become a data engineer. That's usually the transition you have. from a data analyst to a data scientist or to a data engineer. Not to say one role is better than the other, they're all on the same basis. So really, it depends on your interest as your technical capabilities as well. I've got a slide which comes up a little later on that talks about the difference between data engineers and data scientists. So that might help you understand what kind of path you want to go forward. But anyhow, that should be all good. And in terms of data engineering, why is it booming now? Because what I've realized is almost every organization, even before having a data scientist, they kind of tend to have a data engineer. They need to have a data engineer pretty much, because without clean processed data in one stored place, let's call it a database or a data lake, you can't really produce data or insights, quality insights. Suppose a data scientist comes in and builds this prediction model, and that prediction model is purely based on incorrect data. The quality of the model, even though if it's, let's say, a 99% accuracy level or something, which is absolutely perfect, wouldn't be credible. And that becomes a conversation on its own. So data engineering is booming for several reasons, to be honest. The first one would be the expulsion of big data. The volume of data that's being generated by business and individuals is just going on in a unprecedented rate. It's gone crazy now. The amount of huge demand for professionals who can create, who can design and build these systems and infrastructure, it's increasing. It's got a massive opportunity, at least for the next 10 years. I would say anyone who's interested in getting into this field would probably be secure and safe. And there's an increased adoption for cloud computing. So cloud technologies like AWS or Microsoft Azure, these things have taken over. So cloud computing has made it easier and really cost effective for big businesses or even small businesses to store and process large amount of data. So advancement in technology is, again, it's very closely associated to the previous point of cloud computing, and it has helped people analyze and compete data on a larger basis, on larger data sets. So competitive advantage today, if you have, would be that all businesses are heavily investing in data as such. And then, as I said, back to the career opportunities, it's pretty much the same with everybody. In terms of moving forward, we can work in a variety of fields because every single organization needs data. Every organization needs a database. Every organization, be it healthcare, finance, retail, or anything, they would all require these space. And it offers competitive salary, and it will also come with a lot of career advancement opportunities. You can move up to an architect, a data architect, or a data leader, or a data management, or a thought leader. All these are things that you can move into. So that is just a very high level. I see a question, are the slides moving? The slides are not moving. I've just been talking a lot. So if you guys feel like I am talking too fast, just tell me to slow down. I'll go to the next slide, which is the first process of ETL. So people say ETL all the time in data engineering. This is where we get a little bit technical. And ETL process, you must have heard of it because it's probably the first thing that you hear when you start working with data engineers as such. ETL stands for extract, transform, and load. So this process is very, very critical for a data engineer. So the ETL process it involves everything from extraction, from transforming and loading data in all different ways. So you know how different organizations have different data sources, right? So the company that I work with, we've got about 8 to 9 different data sources. And that is one thing that's completely dependent on the organization. Some organizations just have one data. They just look at one data and that's all their processes. So it becomes a very easy process in terms of extracting data. But companies that have a little bit more complex environment where there's more than, let's say, 5 data sources, it becomes a little tricky as such. So ETL, what does it stand for? Extract. The first step of the ETL process is to extract data from different sources. So this includes databases, it includes APIs, or it also includes flat files. It includes anything that you can think of to extract from. So this might be involved a little bit around the SQL process, SQL queries. This is where you use your SQL information and a little bit of Python as well, because to extract API information, you need a little bit of Python knowledge as well, depending on the API that has been provided. So that's the first step of ETL, extract. Second one is transform. Transforming information is pretty much where after the data has been extracted, next step would be to change this into a format that can be easily analyzed by a data scientist or a data analyst. So this might involve cleaning the data to remove duplicates or errors, transforming data types from string to nvarchar, or combining data from multiple sources. So this is very crucial. And this, from a data engineer's perspective, this takes about 50% of all the work that we do, the time that we do. And we just ensure that the quality of data is accurate and it's useful for analysis. That's very, very important. And finally, once we've done all the transformation, the analyst doesn't have access to the data. So you need to load this into a place where people can access. So this can be a target system. This target system could be a data lake, or it could be a database or a data warehouse, something that people can connect to. And this involves writing code to load the data into a target system. So we use something called a JVC, Java-based connection. That's pretty much what we use to push it to an Azure database, SQL database that people can connect to. But there are future technology, things that have progressed since the last time that we worked on it. For example, we've got Apache Airflow or Apache, different solutions provided by Apache to automate this whole process. So if you've got something in the data lake and you've got someone to access it, if I use these terms, like Kafka, all these technologies that people use in current times. So overall, the ETL process is a key part of data engineering. If you are a data engineer, if you want to get into the field of data engineer, understanding this concept as such, even just this level of concept, what does E do, what does T do, and what does L do? And you've got a little bit of SQL and Python knowledge, you can get into this field. It allows us data engineers to collect and transform data from various sources in a format that can be easily analyzed by people. So in a well-designed ETL process, data engineers can ensure that the data is accurate, consistent, and useful for analysis. That's all your objective is as a data engineer. So I work mostly in an Azure environment. So I use a tool called Azure Data Factory for extraction. We can also use other tools which are very specific for different tools of extractions. Like the first thing I can think of would be a tool called ADI that we use in our company. Nobody really uses it if they don't have the need for SAP ERP kind of data source. And then for extraction, and in terms of performing all the tools on the extracted data, we use something called Azure Databricks. Databricks is a big part of our solution provision, and that is a very useful tool that I would suggest you guys getting into as well. I've got another slide coming soon, and that is a little bit on what you can do to get to the state where you can start applying for jobs. Because as you study, when you're studying your, let's say, bachelor's in data science or master's in data science, you don't really get to use a lot of the technologies or tools that you kind of are exposed to when you work as a data engineer. But that doesn't mean that people cannot get into this field without applying basic knowledge or applying basic experience in this field as such. And Spark is like a massive framework. Many of you may have heard of it, and understanding what that framework does will also be helpful. And in terms of loading data, currently what we use, we've got a data lake, something called a Gen 2 storage in Azure. And we've also got SQL databases, pure SQL databases. And this is also something that we use on a day-to-day basis to provide to all the people in the business who use it. So I've got people from finance, I've got people from R&D, I've got people from different departments in the business who connect to the data that I produce to them in a database. So they use Power BI, we're completely a Microsoft kind of shop, and that's what they provide. So if you could go to the next slide, please. And these are just a very high level skills and tools that might be helpful for you if you want to get into this field. And in terms of data platforms, I'll talk to the ones that I have used. Databricks is amazing. So there is this free version of Databricks. If you can get into that and just play around, at least see what are the different environments that you can play around in, that'll be very helpful for you. The next one is, well, it's also got Snowflake and Snaps. So we use Databricks. You can use any of these, and depending on the organization and the decisions that the organization makes, You can choose what to get into. It's very important that you get into something that is accepted by the organization as well. Because apart from these three, I know at least a couple more, which has been introduced. There are full solutioning data platforms that a lot of people don't use because most organizations don't. So being data-driven people, I would assume that you guys know a little bit about these platforms that are used by the most companies before jumping into niche data platforms as such. And data storage, the one that we use, is the thing that you see at the first, which is Gen 2 storage, Azure Gen 2 storage. It's like a blob storage. The best thing about this Gen 2 storage is that it's cheap for the organization. So a lot of organizations use that for storage, and they store data in the simplest formats, and in whatever format you need. You can store not just structured data, you can also store unstructured data. That's probably one of the best things you can do in terms of storage capabilities. So one of them is you can store just PDFs, like an image, or you can store an audio file if you're more interested in audio analysis. But at the same time, it supports normal files like a Parquet file or a PNG file or JPEG file, anything that you are interested in, or CSV file. In streaming technology, this is kind of new, and what we use in our organization is something called Spark streaming. Spark it's brilliant in terms of getting data as we speak, real-time data, IoT-based data, and it's being developed as we speak. Every single day, there's more additional features that's being added, and that's very helpful moving forward. And in terms of languages, I told you, as I said before, it's Python and SQL. To start off with Python and SQL, and then you can work your way through it. And everything that has a basic understanding of that would be enough for you. It's not intense coding. So if you're not a person who absolutely is passionate about coding, and Python is probably one of the best languages you can start off with. So I would suggest having a little bit of understanding of SQL and Python, and then you develop according to the requirements of the organization. And the next one would be BI tools. BI tools, what we use in our organization is Power BI. Another famous one in our space would be Tableau. So it's 99% of the time it's between Power BI and Tableau. I would suggest getting a simple certification in Power BI if you are interested in getting into the field of data analysis or data science as well, because people have been starting to use Power BI for analysis and science purposes. If you can go to the next slide, please. Right. In terms of data engineering, that's very interesting. Data engineering versus data science, because I'm sure all of you have heard of, at least at some step, heard about data science and data scientists, and not a lot of you might have understood the difference between data scientists and data engineering. So throughout my career, I started off in a data analysis and then a little bit of data science, and then I moved into this field of purely data engineering. And there was a reason, because that's more suited to my personality. So it depends on your personality, your interest, and your career objectives. So differentiating all of them, how can we break this down? They're very related, but distinct disciplines within the field of analytics. So the first one, we can break them down. We can say that it's based on the focus. So as a data engineer, your focus is on the development and maintenance of the systems, infrastructure needed to store all the procedures that's involved, the processes, collect data, transform large volumes of data. And data science, on the other hand, is focused on analyzing and interpreting data to derive insights and make predictions and whatnot. Skills would be that data engineering requires a strong foundation in computer science or software engineer and database design. And data engineers also need to be proficient in languages like mainly SQL and Python, but also a little bit of Java if you're interested in advanced software related technologies, and tools like Hadoop, frameworks like Hadoop and NumPy and TensorFlow, all very helpful technologies. And data science would be more around statistics, very much around statistics and machine learning, data visualization, and they need to be, again, the similar language between a data scientist and a data engineer, majority would be Python. And apart from that, I can think of a little bit of a use case for SQL when I was a data scientist, but it was mostly Python and R. And I mainly use pandas, NumPy, TensorFlow when I was a scientist. But then moving on to an engineering space, it's very much in the tool that your company has provided, like Databricks. And in terms of tools, just jumping to the next one, we as data engineers, we involve a lot in the tools like ETL, extraction, transform and load, pipelines, data warehouses, data lakes, and data science. It really involves all the statistical models and machine learning algorithms and visualization tools, again, depending on the organization. And in the end, I would say a little bit about the goal. The goal of a scientist and the goal of an engineer is a little different in the data field. The ultimate goal of a data engineer is to create a robust and scalable data infrastructure that can handle large volumes of data and support business operations. So the ultimate goal of a data science person would be to derive insights. It's always been to derive insights for the business stakeholders and make predictions that can help business decisions and drive innovation. So in summary, while data engineering and data science are both critical components in the data analytics process, they require a little bit of a different skill set and focus in terms of the data lifecycle. The data engineer is more focused on, let's say, building the infrastructure to support the data analysis, and data science is a little bit more focused on analyzing the data to, let's say, derive insights. That would probably be the key difference. So depending on your personality as such, so if you're more of a presenter, if you like doing the common part between data science and data engineering is that you need to be a little technical around what data is, the passion towards data. Yeah. And then moving towards the personality wise, if you're more of a quieter person, if you're more involved in the back end of things and not a people kind of person, then data engineering would be the right choice for you if you like to stay behind the curtains. But if you're more of a person who gives presentation, so as a data scientist, I had to give a lot of presentations to the CEO or the CPO or one of the chief officers on what our data can do. But in terms of a data engineer's role, what I work with the most is data architects or data analysts, insight analysts, and data managers, and really around business analysis side of things, though, not really the higher ups. So, but the other people cannot provide the data without us provisioning them the data. So it really depends on your interest and takes as well. And if you can go to the next slide, please. Yeah, so if you are interested in entering the field of data science or data engineering, because that's how I got into data engineering. I would have never gotten into data engineering if I didn't know what was involved in the data engineering aspect of things. So the first one would be learn the fundamentals. And what do I mean by this? I mean by starting a solid foundation in things you can do, like computer science, mathematics, and statistics. You should be able to be at least able to understand what Python, Java, or SQL can be used. And these can be used for Hadoop or Spark or Kafka. Really, it's just understanding, maybe even this session today, if you do understand what is required in it, and you can maybe start doing a little bit of this coding, understanding in SQL, joining two small tables. How does that look like? Is it something that you're interested in? Because if you're not, you can obviously choose the data analysis part, or you can choose the data science part. They're all equally important roles. And then getting a little bit of an hands-on experience. So that's what I meant by Databricks as this free tool. You can get into using one of their free versions. A lot of the tools that I mentioned, you can use free versions, demo versions or trial versions. And you can start building your own projects, or at least when you go in for an interview, if you are interested in the data engineer role, if you have zero knowledge or zero experience to even the UI of a tool, then it becomes really hard for you to justify yourself. So I would strongly recommend that you look into this. And next one will be building a portfolio. Building a portfolio, again, I understand is very challenging as a data engineer, because if you're a data scientist, you can just, I don't know, pull up a notebook, a Jupyter notebook, and run up your script, and you've got a portfolio. That's something for you to demonstrate. But for an engineer, it's the whole process. So if you don't have your own data being created, how do you show them? How do you say that you're taking care of an entire environment? It becomes a little hard. It always becomes a little hard. And then I would say just using these tools, all the free tools that you can get, showing that you've done these parts, you've done extraction, you've done transformation, and you have done loading in different environments. It doesn't have to be in the same environment because you're not part of a company as such, right? So you can actually say that all these things that you've mentioned are things that you have passion about, and you've got a little bit of knowledge, and then you are interested in developing that for an organization. So the next one is attend industry events. So there are conferences, workshops, and even sessions like this that if you are interested in, if you join and you are interested in learning about technologies and trends. So everything that you need to know is pretty much available out there. So when you attend industry events, like a few weeks ago, a few of my colleagues and I, we went for a conference, a bootcamp session, and that was on Databricks. And we met other people who use Databricks, some people who do not use it as much as we do, some people who use it way more than we do. So having those conversations, even people who never seen or heard of Databricks were there. So these sessions are held all across the globe. So depending on what the tool the company is selling, you just go attend them, you talk to them, and you build that network. And that is very, very, very useful. It's probably one of the best things that I can say in terms of provision of knowledge. Yeah, and pursue a formal education. It doesn't have to be data science as well. If you can just maybe get into that field of data science, because that's what I did. So I studied something that's totally different from data science. I was learning about sound. I was learning about how a song sounds. And then I realized this is not my passion. I want to do a little bit more about maths. And then I came to a data science field, because you can find a lot of masters in data science. You can find a lot of masters in AI now, but I do not know if you can find a lot of information on data engineering, as in masters in data engineering. So pursuing a formal education can be anything in computer science. It's a very generic understanding. You can get into statistics. I know people who've just gone into mathematics who are now working as data engineers, or you can just follow the easiest step, which is data science, because that gives you an option, right? Once you graduate, you can get into maybe a data scientist role, or you can get into a data engineer role, or a data analyst role, data architect role. It just keeps going. There's so many. That's another one. And staying up to date. So that's the thing. That's why I keep emphasizing on not learning the tool. So if you learn Databricks today, and Databricks is going to stay for a long time. Let's say another tool. Snowflake is going to stay for a long time. Let's say Kafka. Any
Richu,
tool,
lost
really.
you. Can you just try and reconnect?
Learn the best out of it now. By tomorrow, it's going to change. There's a new trend and new technologies that's coming in. So you need to keep yourself up to date with what is in the realm. For example, if you just focus on things like SQL and Python, that's like a strong foundation. Just no matter what it is, that's a strong foundation, no matter what tool is proposed to you. And if you also understand the frameworks and understanding of what's required for you to get to a state where you can understand the terms that people are using, it'll be very, very helpful. So getting into this field, if you just follow things like this, because there's no set structure for you to get into a field without any knowledge. And always, you need to be very open, at least, to the field of talking. And you should be very open to the field of understanding what is important for you as a data engineer. And usually most of your clients, or most of the people that you talk to, are data analysts and data scientists. So they understand data. They're not people who have no knowledge of this domain at all. So that becomes a really hard conversation. So I would say if you are a person who enjoys technical conversations, data engineering might be the path for you, and you have a passion towards data science and data engineering. Because I'm not saying data engineering has to have a passion on its own, because I did not have, and I did not know. That's the lot that I would understand. If you want to have a career, or successful career in data engineering, and by successful career, I mean enjoying what you're doing. It should be something that you are truly passionate about. I would say, think about these conversations, think about the differences between an engineer and an analyst, and identify what is the best way. Because in terms of technical capabilities, analyst is probably the easiest that I've seen. When I started as a data analyst, it was probably the easiest in terms of coding, in terms of responsibilities. Then as a scientist, it became a little bit more technical, but at the same time, we had the business aspect of things. Majority of it was talking to other people, making other people believe that the systems that you have, the models that you have, are probably the best for the business decision-making process. And as an engineer, it became even more as a technical space, technical conversation. So yeah, that is that. If you can go to the next slide, please. Yeah, we've come to the Q&A session. Just one more thing before I jump off on Q&A. If I've mentioned things like data warehouse, database, and data lake, and if you're interested in identifying what these things are, it's pretty much, all of them are used for storing and managing data, but they have like fundamental differences. So you hear these words like warehouse, database, and data lake all the time, every single time as a data engineer. And as a warehouse, it's usually a centralized repository for integrated data where everyone puts their data, and it's used for business intelligence and reporting activities. And it's usually historic data. So that's the main difference between a database and a data warehouse. Data warehouse is usually on historic data, and database is on transactional data. As we speak, there's new data coming in, there's new data going out, and that is probably the biggest part of it. And data lake, that is what we work on. That's probably the latest technology that exists in terms of storage. And it's a large centralized repository that helps organizations to store all this structured and unstructured data. So if you've got this knowledge, that's a little bit of an advantage in terms of convincing another person that you are interested in this field or you are passionate about following this. They're made to be very flexible. So you can think of a SQL database, all the data has to come in a table. So it has to have, let's say, 20 columns, and it has to stay that way. So in a data lake, can be in any format, any schema. You don't have to predefine anything. You can just put data in and start working your way through. So this allows scientists and analysts to explore and analyze data without having a structured approach. And that's usually what's happening right now. The data lakes are typically used for advanced analytics, very, very advanced analytics, such as machine learning and artificial intelligence. So you can get into this field, and a career progression in terms of what a data engineer looks like from that point would be AI specialist. You can purely focus on being an AI specialist, or you can be, again, you can go back to your data scientist approach and be someone who focuses on very purely research-based machine learning approaches, or you can move up to a data architect. Data architect is a person who understands the entire space, who understands how data science looks like, data analysis looks like, data engineering looks like, and how can this all be fixed together. That's what a data architect's role or position is when they come to higher level of questions. Right, I have been done with that. If you guys have any more questions, I am more than happy to answer. I still cannot hear you guys, so I would have to have one of those. There's a question in Zoom. Right.
I hope that you can see the chat that I've just shared, Richu.
I can see the chat. Is there
yeah, sure. I'll just forward you the questions in the chat as well, right? Give me just 1 second.
I saw the Q&A. Right, awesome. I can go through that. Now, the first question was is Python era ending? Nope, Python era is not ending at all. We just advance it into different formats. For example, there's something called PySpark. So it's like a Spark framework, and you can use I'll tell you what PySpark is, because this is very important. It's a good question that you raised. PySpark is the Python API for Apache Spark. It's like a powerful open source big data processing framework, and PySpark allows developers to write Spark code using Python. So if you know Python, you can write Spark. So you already know 2 languages if you just know 1 language. It makes it easier for Python developers working with large data sets and performing complex data processing tasks. More people on Azure, less on AWS and Google. Any particular reason? Good. Well, I would say the cost. I have found that our company, because we do a little bit of architectural conversation. Architectural conversation is, how is this scalable? If currently we have 2 TB data, if we are going to have, let's say, 5 TB data, what's probably the most cost efficient one? And we've already, in a Microsoft umbrella, we already use Power BI. So why not just find something in Microsoft Azure? That's the conversations that we've had. But I know that a lot of people do use AWS as well. So if you work for a product-based company, Their data is in S3 buckets. It's all in AWS space, right? So if you are interested in that, I would strongly recommend starting off with Azure, because you can't learn all of them, right? You can, if you had to choose between the three, I would recommend Azure because it's probably the best in terms of widespread understanding. And then AWS, very little people use Google Cloud technology. So I strongly recommend using AWS or Azure coming first. Next one, what development and implementation procedure do you follow for new data systems? So that becomes the whole process, right? So when we start getting a new data source as such, depends on the API, how do you connect to them? So we use a tool called Azure Data Factory, as I mentioned, and we've got a step-by-step procedure, which we've worked with an architect or someone who has architectural capabilities on how do you extract data. We have different layers in storage that we process, starting with an extract layer, and depending on how you process it. So sometimes data comes in as full loads. You get the data, you just copy the data and you just bring it here. As a data engineer, that's probably the easiest process for you. But then when it becomes incremental load or a delta-based load, then you need to start thinking about how the processes and implementation would look like, because I would need to push it into the raw data file. Then the next file format would be Parquet. All of them would be in Parquet first. And then the next file document storage would be curate, and then it goes to extract, or then it goes to a final DBO, depending on how you define your architectural space in terms of solutionizing. So in terms of what procedures we follow, we just follow as and when we get new data, we follow a step-by-step process of extraction, loading, and transforming, depending on the requirement, and push data through. It also really depends on your data flow. If it's real-time data, if it's streaming-based data, and also if it's batch-based data. Majority of the companies use batch-based data. So you get something for one day, you push that through, or you get something for a few hours and you push that through, not as and when you speak, unless it's a very big company that requires a business model that requires data to come in all the time. Hope that answers that. Is only done in structured data, it can be Q2. I'm not really sure what that question means, but in terms of structured data, really depends on what the first part of the question is really. Did you mean a database storage? Because majority of the data engineers, we work with structured and unstructured data. And unstructured data, okay. Do we do data engineering on unstructured? Yes, we do quite a lot. So we've got a new requirement that's come through as a data engineer. They say we've got a table, and that table does get data that comes in, and that keeps evolving. They're saying today it's going to be 10 columns, tomorrow it's going to be 12 columns. So are you guys okay with unstructured data coming through? So that's when you use things like autoloader function, when you use streaming technologies and getting data and then pushing it through. Yeah, without using any keys. You don't have to think about that way of understanding that as such. If you are clear on what you want to go into data science or data engineering, doesn't really excite you much. So to be successful in data science, how well versed should you be with data engineering? Or you don't have to be well versed with data engineering at all. You just need to understand how closely you'll have to work with a data engineer to be a data scientist. So when I was a data scientist, I had constant conversations with the data engineer, because they provide you the data that you need. So if in the real data source that exists, I've got 20,000 columns, let's say, and as a data scientist, I need to provide a prediction model just based on 20 columns. So I need to tell them to summarize that, bring it into a format that I need so that I can start performing my analysis. So you just need to tell them. Usually data engineers are really smart. You can just tell them what they need and they bring it to you. So you don't need to know a lot about data engineering as such. Next, what are the day-to-day challenges as a data engineer and as a data scientist? So I'll tell you with data scientists. Data scientists is you need to talk to a lot of non-technical people. So you talk to, let's say, a project manager who doesn't really understand the technical aspects of a model. So suppose you have an accuracy level of 85 and you're really proud of it, and you come forward saying that I've got an awesome prediction model. But as a project manager who doesn't understand data, the conversation would be really, really hard. It'd be, well, that means 100% of the time the CEO is not going to get this conversation. There's not going to be 100% accuracy level. So how would that happen? And that conversations are really more hard. Convincing the business that your data science model or your machine learning model or anything along those lines are very productive. That's the hardest thing as a data scientist. And also it's a very iterative process. You need to do the same kind of, you work with the same data set all the time, and you keep working on different models, just very iterative. That's what I would say. But what are the challenges of data engineer? Technical, most of them are technical because there are different sources, right? Different data sources that exist out there, and you need to get data from all of them. And getting data is really, really hard because not all of them have an easy connectivity, getting it from this source to your system. So you have constant conversations around what has to be taken, what has to be extracted. So it's more around development related conversations. It's usually easier. I would say it's definitely easier technical conversations than people conversations. So those are the two kind of main challenges I see as a data engineer and a data scientist. Right. How do you find such industry events? How do I find? I find them through LinkedIn. And we have, at least in New Zealand, I'm not really sure of India. I'm sure there must be heaps and heaps in India, but depending on the country that you're based in, or if you're in Australia, they've also got data fields, data domains. If you join one of those, they keep mentioning the different tools, different events that come up. For example, what I've done is I've registered for everything that falls under the New Zealand Databricks environment. So if anything that in any session, if it happens in another city in New Zealand, I get a notification, pretty much like how you may have got notification for the session. That's how I've started. It really depends on conversations and tools and technologies. Yeah, you just reach out to anybody, and usually it's conversations that come up. Because if you think about it, every company, they want other people to learn their tool so that more businesses adopt their tool. So they do their best to push out these kind of events. And you should make the best out of it by attending these and making the best out of understanding how you can use these information. Yeah, I would say all the companies, every single company wants more people to know about their software. So attend all these things, make the best out of it, ask questions, and learn more. To start off with engineering, what tools do we need to be hands-on to get the opportunity? SQL and Python. Start with SQL and Python. I would strongly suggest understanding SQL and Python. Second would be getting into one of these tools, Databricks or Snowflake, and getting into this tool and identifying what are the different things that you can do and work your way through it. It's a very good start. Second one would be understanding the ETL process, the framework like Apache Spark. You can understand what it is and then work your way through it. It's probably the best way to start. And also understanding how the data analysis side of things work is very helpful. A little bit of Power BI information is helpful as a data analyst perspective. That's probably the best things for you to start off with. How important is a formal degree for kickstarting your career? Not very at all, but you need to have something. That's what happens, right? If you're applying, if 5 people apply and 4 of them have degrees, and you're the only person who doesn't have a degree, it becomes an issue in conversation. It becomes a really hard conversation. How do you convince someone? It doesn't really have to be a data science engineering degree. It can be computer science, stats, or maths, or even EC, electronics and communication. If you've got some understanding of logical processing. And if you've got all these certifications, oh, I forgot to mention, certifications are so important. So if you've got no experience, if you've got 0 experience at all, if you've got some certification, they see that you're certified Azure Microsoft data engineer, let's say, or a certified Microsoft data scientist. That puts you a little bit more valuable in terms of who's hiring you, really, in terms of your organizational requirements. They would really suggest that you move forward. So I would say it's almost 60% important that you have a formal degree. Any formal degree really doesn't really matter. What if I want to specialize in BI? space. So we all fall under BI, business intelligence. So in terms of talking about how our team looks like, we've got business analysts, we've got insights analysts, we've got data scientists, we've got data engineers, and we've got data architects, and we've got a data manager and data governance specialist. Depends. It really does go on. So depending on the specialization as such, I would suggest go into this field as such. If you are more interested in, let's say, by BI, you mean Power BI kind of information, more on reporting or analysis of information, I would suggest really getting into just the analysis side of things, just maybe developing your Power BI or Tableau skills. But if you're more interested in understanding the other spaces of BI, I would suggest getting into more technical information around data structures. And then the last one, what made you switch from really, it was just, you get to a point where you understand as much as you can in one field, in that organization as such. Yeah. So when I started working, it was more on NLP kind of programs and very limited in terms of what I could do. But I realized there's a massive scope in data engineers. And also I think it's a Pacific region kind of thing. If you look for data scientist jobs and data engineers jobs, there's going to be way more data engineer jobs than a data scientist job, mainly because many companies have realized that data scientists are building all these prediction models, all amazing models, yeah, and they have been pushing forward all these things. But how effective is it? How efficient is it? So it really becomes a responsibility of another person, a data engineer. And I think I kind of realized that that's something that I was interested in. And I also had the people aspect of things. There was a person who was a lead data engineer back then. So I had a good relationship with her, and that's how we started getting into this field. Because I worked a lot with this person because she built all the data that I needed as a data engineer, as a data scientist, right? And then I realized that what she's working on is even higher and newer forms of technologies, and that's more accepted by an organization. So that's what kind of pushed me into data engineering, and I find it very rewarding. It's brilliant. I would suggest if you're confused between these, it depends on your personality. Just don't go for data scientist just because of the word scientist. That's what I did when I started, but I realized that engineering is a little bit more my thing. And that would be all in terms of questions. Right, I see your message, Josh. No, thank you all for joining. And as I said, if you've got any questions at all, even after the session, please reach out. I am more than happy to answer them on LinkedIn. If you've just type in Richu Phillip, or if someone's got any questions, just reach out. I'm more than happy to help, be it with in the field of data engineering or data science, or scholarships and anything in New Zealand as such. Awesome. Thank you.
Okay, everyone. So I guess this is the time where we have to part ways. We won't be having to keep Suchit all the way to here, right? All right, guys. As always, I'm sharing the feedback form with you guys. I hope that you guys enjoyed this today's session as well, regardless with all the technical issues that we had. There you go. The feedback form is in the chat, and I hope that everyone fills that out. Always helps us. All right, great. Thank you once again for joining in.